The Arduino Zero is based on a powerful microcontroller, but it's also a very energy-efficient device. It is an excellent choice for battery-powered applications because it is very nimble when it comes to power consumption. The Arduino Zero consumes a fraction of the power that the Arduino Uno does for the same tasks. It does this because of the power characteristics in the SUMD microcontroller and because of the more efficient power sub-circuit on the board. In this lecture, I'll describe these power features and we'll compare the actual current draw of the Zero against the Uno. Let's get into it. Hi. In this lecture, I will compare the energy consumption of the Arduino Zero against that of the Arduino Uno. And I'll show you that the Arduino Zero is far more efficient than the Arduino Uno, even though it's a lot more capable. It's got a faster processor, can do a lot more things as compared to the Arduino Zero. So you may be wondering how that is possible. And the answer is that there are two things that come into play. First, the Arduino Zero has got a more efficient processor. So the SUMD21 processor has got really interesting power saving and power efficiency features. And then there's also the design and the components used in the power supply for the Arduino Zero board. So those are also able to provide efficiencies in energy consumption. So before I go ahead with the little experiment and the comparison, let's have a look at the schematics. So in the Arduino Zero board webpage, you can have a look at the schematics by clicking on this button here. I've already loaded it. So in the first page of the schematic, let's have a look at one of the headers. So this is the power header, and in pin 8 is the V-in pin, which is the same as the V-in pin in the Arduino Uno, and you can connect power to pin 8 anywhere between 5 and 12 volts will do, and that is regulated. So if I follow the in symbol here, it will take me to the second page of the schematic, and here you'll see that external voltage input, external V-in, becomes input to the LM2734Y module. This module is from Texas Instrument, and it's a step-down DC to DC regulator. It's a very efficient component. It converts voltage input into voltage that the SUMD microcontroller can use, at 3 volts that it can use. There's a lot of information about it here, but the bottom line is that this is a very efficient way to convert voltage input into the voltage that the microcontroller requires. In comparison, the Arduino Uno only uses a simple voltage regulator, which basically wastes a lot of power as heat in order to make this conversion from voltage input to the 5 volts that the microcontroller is using possible. Another thing that plays a big role in the efficiency of the Arduino Zero is its microprocessor, or the microcontroller. So the SUMD21 unit contains a few interesting features in regards to power consumption and low power features. It's got the ability, just going to do a quick search here. So it's got idle and standby sleep modes, and a feature called sleepwalking of peripherals. Let's have a look at that. According to the documentation here in the datasheet, the SUMD21 devices have 2 software selectable modes, sleep modes, idle and standby. And in idle mode, the CPU is stopped while other peripherals can actually be working. And in standby, we've got all clocks stopped, except for those that you can programmatically select. So you can be doing, for example, you can have an interrupt timer. You can let that run while communications with an EPROM, for example, are stopped. And there's also this feature called sleepwalking, that allows peripherals to be woken up based on predefined conditions that, again, you can set up programmatically. So you can have some parts of the microcontroller turned off while other parts are running, and of course that conserves considerable amounts of energy. I'd like to do a comparison now between the Arduino Zero and the Arduino Uno, and I'm going to use this sketch, and all this sketch is doing is to take a reading from analog pin 0 and then print out the value that it read in the serial monitor and then do an analog write to pin number 9. I'm not going to have anything connected though to the two boards, so the input will just be reading random values. And I will use my power supplies to measure the current that each board draws by running the exact same sketch. So first I will upload the sketches, so I'll connect the Arduino Zero first via the programming port and upload the sketch. Okay, done. And then I'll do the same thing with the Arduino Uno. Okay, so now select Arduino Uno and yep, the port is correct, and upload the same sketch. Done. Now I will disconnect the computer from both boards and I'll connect the boards to my power supply. So the yellow cable from the first power supply is plus. I'm going to put that in VN of the Arduino Uno, and then I've got minus that goes in the ground pin of the Arduino Uno. The red cable from the second power supply will go to the VN of the Arduino Zero, and the yellow will go to ground of the Arduino Zero. Turn on the power supplies. Both are calibrated to 12 volts output, and these are the maximum currents that will be supplied, so it doesn't really matter, it's not going to reach that far. The first one is connected to the Arduino Uno, and the second one is connected to the Arduino Zero. So turn them both on. And the difference is very big. The Arduino Uno is consuming 0.054 amps. The Arduino Zero is consuming 0.008 amps, 8 milliamps. It's a huge difference. Remember that both of these boards are running the exact same sketch. So you can see that the Arduino Zero is a very good candidate for projects that depend on a battery power supply. The battery is going to last much longer than if you use the Arduino Uno. And of course you get the extra computational power of the CPU itself.